Hi everyone, today we're looking at Module 7, Lesson 9, and the topic that we're going to discuss is the decimal expansions of fractions. And our learning target for today says, students apply knowledge of equivalent fractions, long division, and the distributive property. To write the decimal expansion of fractions. So we're going to look at a couple different things. We're going to look at equivalent fractions, long division, and distributive property in order to change a fraction to a decimal. So the first example we're going to do is 5/8. And we know that 5/8 is a finite decimal because 8 can be written as a product of only 2's and 5's. And that's a rule that we learned in lesson 5, 6, 7, 8. But what's helpful with that is that if we do the prime factorization of the denominator 8, we get 2 times 2 times 2. And in order to write it as a power of 10, we want to pair each 2 with a value of 5. So 2 times 5 is 10. So instead of having a denominator of 8, I'm going to multiply by the common factor of 5 times 5 times 5, which is approximately 125. And I'm going to do that with my numerator and my denominator to get an equivalent fraction that has a denominator using a power of 10. So my numerator turns into 625, my denominator turns into 1,000, and now I have a fraction written as a power of 10. This is going to be helpful when I try to convert into a decimal, right? Because if I look at (625) over 1,000, I can write that decimal value as 625 thousandths, which you'll see in just a minute. Another helpful method is to use equivalent fractions. So 5/8 can also be multiplied by a common factor of 2. You get 10/16, which gets multiplied by a common factor of 5. And now I have 50/80. If I multiply this by 10 to the third power, I get 5,000/8, which simplifies down to 625. So let's show that. 5,000/8 times 1/10 to the third is the same as 5,000/8 divided by a common factor of 8 gives me 625 times 1/10 to the third, which is 625 over 1,000, equals 0.625. So in both methods, by finding either a power of 10 for the denominator or by using common factors to create an equivalent fraction with a power of 10 in the denominator, I can still write any fraction that I know is going to be finite as a decimal. So we can take any finite fraction and rewrite as a power of 10 to be simplified as a decimal expansion. And that's really helpful in terms of calculation. The next thing I want to look at is Module 7, Lesson 10. And this has to do with converting repeating decimals to fractions. And our learning objectives for this lesson say students know that intuitive reason why every repeating decimal is equal to a fraction. We're going to look at kind of how to use some algebra to figure that out. Our second learning target says students know the decimal expansion of rational numbers will repeat and also that irrational numbers cannot be represented as a fraction. So for example, if I have an x value that's equal to 0.81 repeating, then x is equal to 0.81818181 and so on and so forth. But if I multiply both sides of that equation by 10 to the second power, I can get 81.81 repeating. And I can redefine the value for x as that repeating piece of the decimal. So by dividing both sides by x, or by saying, that 100x is equal to 81 plus 0.818181, I can remove that x value from each side. So subtract an x, and I get 99x is equal to 81. I basically removed that repeating decimal component of my equation to allow me to solve for x. So after simplifying, I get 9 over 11, and I can put that right into my calculator to make sure it comes out as the repeating decimal 0.81818181.